we're going to learn about removing a point discontinuity in a rational function. And throughout this video, we're going to use this rational function right here. F of x equals x plus 2 over 2x squared plus x minus 6. We're going to go through, investigate the different discontinuities that we have in this graph, and then see which ones we can get rid of, and then finally go over how to get rid of it. So here's the graph of this function. So we're going to take this function apart here a little bit, see how we get these different things here. So we're going to start, as we would for any rational function, we're going to factor the numerator. So we're going to have x plus 2 over x plus 2 times 2x minus 3. And from here we know that x plus 2 cannot equal 0, and 2x minus 3 cannot equal 0. And this is because they're both in the denominator here, and we can't have 0 in the denominator. So x here cannot equal negative 2. Here we can just solve this, and we get x cannot equal 3/2, or 1.5. Now, if we take our function over here, you can notice that we have a factor that's the same in the numerator and the denominator. Each has an x plus 2. So we can actually simplify that, and we get 1 over 2x minus 3. So we've got these two places here, x minus 2, and so x equals negative 2, and x equals 1.5. These two places where our function is undefined. So if we can sketch a graph on here on a calculator up by hand, and you'll notice that at negative 2, at x equals negative 2, we have a point discontinuity. We got a hole in the graph because we were able to cancel out a factor here. It was in the numerator and the denominator. And then this other one here, 2x minus 3, which told us that x cannot equal 1.5, that's where we have an asymptote discontinuity. So we can't remove the asymptote discontinuity, but if we could somehow get rid of this little hole in the middle of the graph here, we would be able to remove this discontinuity. And that's exactly what we're going to do. We're going to rewrite our function without this little gap here. So to do that, we want to figure out if x could be negative 2, what value of y would we get? So if x could equal negative 2, what is f of x? And, we could look at limits, we could see what it approaches, we could do it numerically, and look at the graph and all this stuff. But we have here this function that we've already simplified out or gotten rid of, the thing that stops x from equaling negative 2. So let's just substitute it right into here, because this function down here is the exact same thing as this function at every point except for negative 2. So if we do that, we get 1 over 2 times negative 2 minus 3, which is negative 1/7. So if x could equal negative 2, f of x would be negative 1/7. So we would have this point, negative 2, comma, negative 1/7. So, and that's all we need to do, because now we know what this could be if we were allowed to define it. So we can redefine f of x as, and we're going to make it a piecewise function. We have our open curly bracket, and it's going to be our original function, x plus 2 over 2x squared plus x minus 6. And this is anywhere as long as x does not equal negative 2. But if x is negative 2, our function is just going to be negative 1/7. So we're going to put negative 1/7 if x equals negative 2. And that's it. This allows us to remove the discontinuity. And if we were to look at this graph of this function here, we would have this exact graph that we've got here, but we would not have a discontinuity here at x equals negative 2.